Watch closely. When I press start, motor 1 turns on immediately, but motor 2 does not start yet. Instead, a timer begins, say 10 seconds. After that timer expires, motor 2 turns on. Then, another timer, 10 more seconds, and motor 3 turns on. Hello and welcome to the next project, Sequential Motor Control. Not just one motor, but 3. And they will start one after another, like a choreographed industrial dance. First, we select our controller. For this simulation, I am choosing the Siemens S7-1200 CPU 1214C DC-DC-DC. Reliable, fast, and perfect for sequence logic. Once selected, we navigate to the main OB1, the heart of our program, and we begin building our ladder diagram. No complex code yet, just pure ladder. This PLC ladder logic diagram controls a sequential, timed loop of 3 motors: motor 1, motor 2, and motor 3. Each motor runs for 10 seconds before automatically starting the next one and stopping itself. Sequential control adds time-based staging, perfect for conveyor systems, multi-pump stations, or any process where equipment must start in a specific order. The ladder logic is clean, the HMI is color-coded, and the operation is repeatable. Here is a brief breakdown of how the program functions step by step. 1. Starting the sequence, motor 1. The trigger pressing the normally open NO start PB completes the circuit, assuming the normally closed stop PB is not pressed. Interlock. The logic checks if motor 2 is off. Motor 2 NC contact is closed. If it is, motor 1 turns on. Seal in and timer. Motor 1 uses its own contact, motor 1, to seal itself in so it stays running after you release the start button. Simultaneously, it triggers the on-delay timer T1, set for 10 seconds. The sequence progression, motor 2 and motor 3. Switching to motor 2. After 10 seconds, T1 finishes timing and its output contact, T1Q, closes. This automatically starts motor 2. Stopping motor 1. As soon as motor 2 turns on, its normally closed NC contact in the first rung opens, breaking the circuit and shutting down motor 1. Now let's make this visually stunning. I open my HMI screen and from the toolbox I select rectangular elements. Switching to motor 3, motor 2 runs for 10 seconds until timer T2 finishes. The T2 Q contact then closes, starting motor 3. Consequently, motor 3's NC contact opens in the second rung, shutting down motor 2, creating the loop or restarting. Looping back, motor 3 runs for 10 seconds until timer T3 finishes. When T3Q closes in the first rung, it restarts motor 1. The cycle repeats. As motor 1 starts up again, its NC contact in the third rung opens, shutting down motor 3. The whole 30-second cycle, 10 seconds per motor, restarts from the beginning. The start button, green. The stop button, red. Clean, industrial, beautiful. Here is the logic. We have only 2 physical inputs, a start push button, green in our HMI, and a stop push button, red. But 3 outputs, motor 1, motor 2, and motor 3. Initially, all are gray, representing standstill. But here is the creative part. When motor 1 runs, it turns blue. When motor 2 joins, it turns yellow. And when motor 3 finally starts, it turns red. 3 motors, 3 distinct colors. One glance tells you exactly which stage the sequence is in. Let's run the simulation. On the left, our ladder logic animating in real time. On the right, our HMI. I press the green start button. Instantly, motor 1 turns blue on the HMI, and on the ladder, the seal-in contact closes. 10 seconds later, motor 2 turns yellow. Another 10 seconds, motor 3 turns red. The sequence is complete. All 3 motors running, one after the other. Watch closely. When I press start, motor 1 turns on immediately, but motor 2 does not start yet. Instead, a timer begins, say 10 seconds. After that timer expires, motor 2 turns on. Then, another timer, 10 more seconds, and motor 3 turns on. That is sequential control. One motor after another, no skipping, no overlapping. But how does motor 1 stay on after I release the start button? The answer is our old friend, the seal-in contact. A normally open contact of motor 1 wired in parallel with the start button. Once motor 1 energizes, it holds itself. And the stop button? It is a normally closed contact, placed before all motor coils. How to stop it? Pressing the stop PB at the very top left will break the power rail to the entire logic block, immediately shutting down whichever motor is currently running and ending the sequence. One press of the red button, and the entire chain de-energizes. All 3 motors stop instantly. Safe, simple, effective. Now I press the red stop button. What happens? Everything de-energizes instantly. The ladder shows all contacts open. The HMI shows all motors returning to gray. This cycle will repeat again and again, exactly the same, every single time. Try building it yourself, simulate it, modify the timer values, and as always, happy engineering.